It's become ridiculous.
Gosh. Okay. It's always a mess. Hybrid is hard. Online is easy, in person is easy. Hybrid's a nightmare. But anyway, yeah, so this is an example. So this is what the system did. A doctor talked to a patient. That was transcribed as something. Then the NLG system, the summarizer, took this and summarized it for the medical record in this kind of medical lingo, right? So the consultation was, hello, how can I help you? Patient, I just had some diarrhea for the past few days. You go to the toilet, blah, blah, blah. And here you get in the note 378x of diarrhea. So you're summarizing this 10-minute discussion in this kind of medical lingo. And that's a task. And it's an important task, right? At least in the UK, in this country, where a doctor talks to the patient, this kind of something must be entered into the medical record. So anyway, so they built a system and they wanted to evaluate it, right? How good was the system producing this kind of thing? And my student did all these kinds of evaluations. So the first one was ratings. So we did that. So they went to doctors and got them to use it and then said, how usable is it? How easy is it to write up your notes using the system? Okay? And that was a scale of 1 to 10. This is a rating system, right? You ask people to use it and give it a rating. Obviously, usability is really important, and it's hard to assess except by a rating scale, but it is subjective. That means that it depends on if someone's hungry or angry or depressed or stressed, or even their personality will affect the rating. So it's good to know this information, but it's subjective. It depends on the person, the individual, on their mood. So you have to keep that in mind when we're doing this kind of evaluation. My student then also went to the doctors and said, okay, here's a summary, find the mistakes in it. So they went through and they very carefully found different mistakes and put into categories, like contradiction, where the summary says, no family history of bowel issues, father has history of colon cancer. These are contradictory. Summary said brother has diabetes. Actually, the patient said mother has diabetes. So we got doctors to go through the summaries and just pick out individual errors, okay? This is what I call annotation evaluation. It's not a rating. Someone's actually annotating specific problems in the text, okay? That's another kind of human evaluation, annotation rather than rating. The student then also did task-based evaluation where he told doctors, okay, here's a summary, go fix it up. And he timed them, okay? So the summary had mistakes in it, he missed out some things. So he told doctors to fix it, to post-edit it, and timed how long it took, okay? Now this is very useful, right? We really want to know how long it takes to use a system, what's the impact on people. But we need, of course, need to keep in mind that this kind of evaluation of task performance depends not only on the quality of the summarizer, but also on things like the user interface, user training, workflow, etc. Okay, so it's a very important kind of evaluation. It's looking at much broader than just the quality of the language one. And then finally, he took the system and he deployed it for real. So people use it for real, doctors use it for real when working with patients. And then he timed them, so he knew how long it took them to manually write the summaries before they had the system. And he measured how long it took them to do the post-editing after it was installed. We found they had a 9% speed up, right? So basically using this system was 9% faster than doing it just purely manually. Okay, and that's real deployed system. Of course, this isn't very good. Probably isn't worth deploying a system from using 9%, given all the complexities of AI technology and support teams and all that. But again, as an evaluation, I think this is the kind of thing we don't see very much of in the community. I think it's a real shame. We want to know if you put it out for real, use it for real, what happens. So anyway, I'm just trying to, the point I'm trying to make here is that.
But there were fewer errors.
Yeah, that's true. And so one thing that I thought was fascinating was they actually, when they did this study involves timing the doctors, they also got new doctors to check for mistakes in the summaries. And actually there were fewer mistakes in the post-edited computer summaries in the purely manual process. So the LLM plus human workflow gave you a better product than the pure human workflow. I thought that was a nice finding. So, yeah, we looked at mistakes as well. So. But again, it's nice to do that in the real deployed context. Well, again, the point I could talk for the entire talk about this, but just trying to make the point that a lot of people think human evaluations all about rating things on a scale of 1 to 10. But that's only one kind of evaluation. We can also ask people to find mistakes. We can time them or whatever in certain tasks, or we can deploy it for real and see what happens. And certainly, I personally think I'm a bit skeptical of this kind of thing now. I think if we do one of these, it's better than doing that. Okay. Yes, that was the first. Just keep in mind, there's lots of ways of doing human evaluations, and don't just assume it's all about getting ratings. So the second thing I wanted to talk about, again, I could speak for an entire hour about this, but I want to cover a few things quickly rather than go into great detail. So there's a lot of interest now in hallucination, which I think Jack is going to talk about. So as we all know now, large language models, when they generate text, they make mistakes, they hallucinate. And so from an evaluation perspective, you need a way to detect these hallucinations. So my student who's doing this, he's working in the domain of summarizing sports data, what's called the road-to-wire task, maybe you've heard of. And what happens here is you take in data, from American basketball, game data. So it's like number of points scored, it's not like play by play. You produce a summary of that like a sports writer would produce. Okay. Let me just give you, here's an example. This is what the input data looks like. This team, the Grizzlies, coming into the game, they had won 5, lost none, scored 46 points in the first half, et cetera. And player 11, Mark Gasol, played for the Grizzlies, got 18 points, 5 rebounds, blah, blah, blah. So data looks like this. The task is to go from that into something like this. And the Grizzlies 5-2 defeat the Phoenix Suns 3-2 Monday. Okay, that's the task, yeah. Classic data to text generation task. So from an evaluation perspective, right, there is a sort of standard way of actually finding mistakes here, which was developed by Weisman, which is basically you ask Turkers how many there are, right? So Weisman in 2017 said, well, just get crowd workers, Turkers, to tell you, count the mistakes. And that's the evaluation. And it's been used by at least dozens, maybe hundreds of papers have done this. And it's a really bad way to evaluate hallucinations. So here's some evidence. So here's a paper put upon the Pasta 2021, which does this, right? Uses this protocol to evaluate hallucinations. And here's one example where they count the number of errors in extracts from corpus text. The point here is the vision paper reported 0.07 errors. And then we had two, as part of the replication project, I'll talk about soon, we had 2 other labs replicate the same experiment. One lab said 0.66, second one said 1.525. Second lab rerun the experiment with a different set of evaluators, got 0.0625. And then this is our methodology, got 0.5. But the point, look at these numbers, right? 0.07, 0.66, 1.525, 0.625. They're all over the place, right?
Well, how do you compute that speed error?
Right?
How is it? What does 0.66 mean?
That means that if you do this protocol of you ask Turkers to count mistakes in the text across the test set, on average they find 0.66 mistakes. This study. The exact same study here, 1.525, here 0.07. This is the exact same experiment, right? We took the exact same experiment, exact same text, exact same mechanical Turk interface, instructions, and you run it several times, and you can see how different the results are. Okay? And that tells you that these numbers are meaningless. This is a really bad way to evaluate. So this is a really bad human evaluation because the numbers you get are all over the place. There's no referability. Okay? That clear? Makes sense? Okay.
So that means there's an error. How many games? How many summaries that is you have? For example, 1.5 B.
So this means that if you run 10 checks with this experiment, I think about 100 checks being run. So they found 152 errors. He found 7 errors. He found 66 errors among these 100 checks.
Okay.
Any other questions?
Okay.
Okay. So this is the way people are doing it. As I said, this has been done by dozens, hundreds of papers, but it's really not a good way to do a human evaluation. Yeah, so you can't trust these numbers, right? They mean nothing. It's too variable. And it's basically because it's a very, asking Turkers to count the number of mistakes. It's a very complicated task. It's not very well defined. What is a mistake? And the Turkers, basically, they probably don't care. They might know much about basketball. So it's kind of, you can see why it's a terrible way of doing a human evaluation, but it was still done by tons of papers. And that's the kind of thing, I guess, that really concerns you, right? I want people to actually think about, is this a good evaluation? And if it's not, do something better. So anyway, we developed our own protocol, which I think basically it's an annotation protocol where we asked people to go through and not tell us there are 5 errors, actually mark each error, right? So rather than us to count, they actually flag individual errors, which I think is more reliable. Done in Microsoft Word, rather than making a fancy UI, we just use Word, keep it simple. And we also got the people doing it, they actually were Turkers, so we put them through a vetting test and various quality checks. It also gave them very detailed instructions. So here's an example of what you get out of this. This is the thing I showed you. So this was basically, showed you from one of our systems we looked at, and you can see if you put it through this process, everything about a mistake, right? So remember Grizzly's 5-2, go back to the data, the win-loss record is 5-0, yeah, not 5-2, it's 5-0. I think it was Wednesday rather than Monday. Okay, the Grizzlies had a strong first half, but they outscored the Suns. So if you look at the data, actually in the first half, the other team had more points. So anyway, so this kind of thing, this is probably a somewhat extreme example, but you can see how there were a lot of mistakes here. And so our protocol that people went through, and rather than telling us there are 10 mistakes, they said, okay, that's a mistake, should be 0, that's a mistake, should be Wednesday, blah, blah, blah. So it's very complete. And we also asked people to categorize them into categories, like wrong name, wrong number, wrong word. I should say other people that picked up this protocol, they tend to adapt the categories based on the domain. So some people, this is the categories we use, the people who have picked up our protocol often tweak the categories a bit, but it depends on your application domain. And we actually had a process where 3 people did it, and then we combined all 3. That's probably overkill because we actually have a very good inter-annotator agreement. Again, most people who have picked this up just have one annotator do it, which is probably fine. Because we do see very good agreements, so really probably don't need 3 people if you want to be like super careful. And it worked, right? I mean, we, our paper, was a very good agreement. lots of quality checks, and they all pass by. So this is a good way, right? This is what I'm trying to say is this is a bad human evaluation to detect hallucinations. And this is a good way of doing it. And so that's, we're going to go from the bad to the good. I could go on about this. Yeah, I just maybe it's measure one interesting point because people talk about hallucinations quite a bit these days. So sometimes you see things that are wrong, but what the mistake is ambiguous. So if I say the statement Mark Gisco scored 15 points, that's wrong because he scored 18 points. But this other guy scored 15 points, right? So I can fix that statement, Mark Gisco scored 15 points either by saying the number, Gisco scored 18 points, or changing the name, Thomas scored 15 points. So there's a mistake, it's wrong, but what the mistake is ambiguous. Could be, either one could be wrong. And so, yeah, I think even when you talk about hallucinations, is sometimes there's a mistake, but what it is it could be, it's ambiguous. And there are cases we saw one day where, you could annotate something in like very different ways. It's clearly wrong, but you could annotate it in very different ways. Maybe I'll skip the rest of this. Yeah, this was fun. I said, we were interested in how many mistakes people made. So we got stories written by sports writers. Because we thought, if you know how many mistakes sports writers make, that gives a target, for the computer system. And so we ran sports writing checks through our protocol, got an average of 1.5 mistakes per story, which I thought was quite high. It was much better than the systems a few years ago. I think it's also better than what you get now out of things like ChatGPT. You're still getting kind of mistakes in ChatGPT, although it's not. Obviously, it's better. But the point is not zero, right? Because sometimes people told me, well, if you want to use a summarizer in a GSIM, it's got to be perfect, right? Mistakes are not allowed. Maybe that's true in medicine, but in sports, clearly, if humans make 1.5 mistakes per story, so there's some tolerance for mistakes. And so I think it's useful for us to know, this kind of thing with building systems, what's the acceptable level of hallucination. And in sports, it's actually non-trivial. Again, different in like medical science. Okay, so anyway, just summary. We want to be interested in this task, version hallucinations. We realized that if we were doing it, it was really bad. So we developed a new one, which works much better. And I just think in general, the point is that we need to, like anything else, just keep an eye on how well our evaluation techniques work. If they don't work well, we need to improve. Right. And it's easy to say, but I'd like to see more people actually doing that. The third thing I'll talk about, again, very briefly, is reproducibility. So we're running a project where we're getting a bunch of partner labs to reproduce published evaluations. So we take evaluations that were published in a good venue like ACL Tackle and ask people to reproduce them and see if you get the same results. And this is actually, that's where this comes from. And sometimes reductions are really bad, but that's the worst case, right? That's the worst we found so far. Sometimes they're better. But anyway, I just wanted to say that two things we found that I thought were quite depressing, two high-level things I found that I thought were really depressing, is that most people didn't want to help us. We said to people, we want to reproduce your experiment. And they just didn't want to help us. I thought it was depressing. And also, we found a lot of what I call execution errors, where there were code bugs or reporting errors, where, people, what we wasn't think it was wrong, not because they're poorly designed, but because people just were sloppy. Which I guess shouldn't be surprising, but nothing people talk about very much. The first experiment, right, so if you were, I know, has any of you had done reproduction studies with people? Okay, maybe no. Okay, so if you want to reproduce an experiment, you usually want to get help from the author, right? If it's all complicated, you need help. So for instance, for human evaluations, we want to know the user interface, who the subjects were, et cetera, and that's usually not in the papers. So we tried to, and so we got these papers from ACL and TACL, trying to the authors and saying, will you help us do this experiment? 61% of people didn't respond at all. We sent, several emails. Nope, no response. 26% responded in some way, but couldn't help us. Only 13%, 1 in 8, 13%, actually gave us what we needed to do the experiment. And I don't know, I think that's dreadful. Clearly most people in our field don't respond to questions about their publications. They also don't correct papers, right? We've seen a lot of cases where published papers are wrong, but they're not corrected, even though they also know they're wrong. And it's typically, I do some work in medicine, right? So in medicine, there's a strong feeling that after a paper is published, the author has to kind of answer questions and correct it. Certainly, for example, in the British Medical Journal, says in the guide to authors, authors have an academic duty to respond to criticism of their work. You don't see this in NLP venues or actually, AI venues in general, you never see this, right? There's no expectation that people have to respond to questions about their research once it's published. Once it's published, you walk away. I think that's really bad. I could pontificate about this, but I think, for scientists, we want papers which other people can build on. And that means that if our papers are wrong, we have to acknowledge it. People have questions, we have to answer them. Otherwise, they can't build on our work. And that means we're not scientists. I'll move on. I can kind of, I'll take about this, but you get the point, right? So that was one thing I thought was quite depressing, that people just didn't want to help us reproduce. The second thing we found that I thought was quite depressing was we had all these what I call execution problems, right? So we saw cases where the numbers in the paper didn't match the data. So we had the data, and we had the paper, and we could see that the words in the paper didn't match the data. We had code bugs, I'll give you an example in a minute, where the experiments didn't mean much because the code that ran them was wrong. Outliers. So when you do an experiment with human subjects, people often look for outliers, which maybe turquoise don't care. And that's okay, right? But we found people doing very aggressive outlier elimination. So limiting, quote, outliers, not because these were turquoise who couldn't care less, but because it was inconvenient. And by dropping the outliers, they got better results. Which is, not good. Really bad user interfaces. So again, human evaluation has got to be a good UI, and we saw some really terrible ones, and also some ethical issues. So this was depressing. These are, again, ACL and TACL papers, both the best venues in the NLP field. So here's an example of a code bug. This is a script which basically there's a bunch of data files which contain outputs of NLG systems, gold, baseline, human text, sys1, sys2. So this thing basically, this is a script which Python programmer takes these output files, turns them into mechanical Turk instructions. And it's buggy. Does anyone see the bug?
Yeah.
What's the bug?
56362.
Right, that's the bug, yeah? Easy to make. You guys are all programmers. right? Very easy to type the script and put in a 2 rather than 3, or maybe the guy, I don't know, maybe use like copy and pasting and forgot to update. But still, it means that ran the experiment, basically, the subject saw this twice. Never saw this 3, yeah? So, yeah.
I hope the 6.3 was not the system to be evaluated.
So, I think he had a couple of variants, right? He was in like an ablation study, so they were different. You know, they was like the full system and partial systems, but still, you know, it's you know, it's such an easy mistake to make, right? You guys are programmers, right? You can think of how easy it is to do this, but yet it messes up the result.
And what about the first anti-slash? Is it your mistake or the mistake in the script? I mean, the first line is expected to be ended with a
That's probably my
backslash.
mistake. Sorry, that's my
It's your mistake.
I'm guilty too, you're right. I'm guilty too. And I just, you know, I mean, you know, so we know from software engineering that if you have a commercial programmer, yeah, working with a very high quality software quality assurance team, you'll get code with 1 or 2 bugs per 100 lines of code, okay? So high quality commercial programmers working with a good, very good testers, result is code with 1 or 2 errors per 100 lines of code. Now, I think most researchers and PhD students, some of them have background as commercial developers, but I've never seen anyone, any PhD student researcher in academic context, working with a high quality software testing team. So I assume that when we write code, probably got more bugs than this. And so I think it could be a huge issue, but no one ever talks about it. I mean, I just, you know, it seems to me that this could be a major problem in a lot of what we do, but it's, no one talks about it, which, yeah, maybe we should. We've seen other examples, like you can look at our paper if you want to see other examples. I should just say, by the way, that when we talked to the author about this, first of all, he said nothing, right? And then we told him they're going to put it into a paper we're writing. And then he said, well, wait, he told me, we didn't actually use this code. It's in my GitHub repo. You know, he's got a paper with a GitHub repo with it. He said, oh yeah, this is part of the repo, isn't the code that I use. Okay, well, can you show me the code you actually used? No, sorry, I can't, it's gone. So, God knows what happened, but for sure, if the GitHub repo is not the code you use, that's actually a problem itself. Because what's the point, right? Anyway, so yeah, again, one thing that I think people should do is just, a lot of the mistakes that we've seen could be detected by just sanity checking, right? You know, do you have, is there a pattern? You know, do the SIS2 and SIS3 categories look the same? You know, so what I tell people is, if you're running an experiment, some people just look at the stats at the end. Actually, this applies to metrics as well, right? So rather than just looking at the final stats at the end, look at some of the detailed evaluation results and see if it looks a bit weird. If it looks weird, investigate why. Either it's a bug, in which case you want to fix it before it's published, or it's some amazing discovery, in which case you'll be famous, right? But either way, I just say, look at the actual detailed outputs and see if you see anything strange.
Yeah, but even if you would run it in this way with, I mean, Turkus evaluating twice, system 2, maybe you wouldn't get the identical results, but slightly different. How do you detect that? That's a challenge too, no?
We detected it like this because the people that do the replication, they actually say, wait a minute, what's going on? Why is this? And so our lab did this, right? We didn't do it ourselves. We got our partners to do it, and they did this. And that's why they picked up these errors. They were very good. I mean, they picked up some, yeah, they were very good at detecting weird stuff and then trying to understand why. So you know, if you don't do this, you wouldn't see it's a problem. And, you know, so in the first phase of this project in reproducibility, we reproduced, well, our partner reproduced 5 papers. Every single one had these problems in it, 100%. So, yeah, not good. That's why it's depressing. Anyway, just to say that more recently, what I've been going through, we're going back to our partners and asking them, okay, now they're going to be working with us for a while, what do you think are the most important things to enhance reliability of results in human evaluations, reproducibility? So here's what they said, right? This is, you know, guidelines training. This is by far the most common comment is people told us. Subjects have to know what they're doing, whether it's good guidelines, examples, training. You need to know what they're doing, and that was the most common comment by far from our partners. Second most common comment was number of subjects. People said the experiments were often underpowered in a statistical sense, like not nearly enough people doing it. Of course, like in psychology or medicine, if you do an experiment, you very carefully estimate the number of subjects you need using a power calculation. No one in NLP does that, or it's very rare in NLP. So a lot of the experiments needed more subjects, and that was learned. And then other things they mentioned that were interesting, you know, filters on crowd workers. So using Turk mentor equivalent, you can actually select who you use. That's actually really important. Representative, right? So this came out like, for example, the system is summarizing doctor patient consultations in English. You don't want someone who's not a doctor to evaluate it. Or if it's summarizing in general, maybe news articles in English, maybe you don't want someone who's Chinese to evaluate it, right? Who's not an English speaker. We were saying the subjects have to be representative of the users. This one, I would repeat. This is what one of my people said. One of my guys said, I think the main question is, does the researcher care about whether his experiment is reliable? So yeah, maybe he's right. This was the most extreme response when I asked people. But yeah, usually people just plot numbers and don't care what numbers mean anything. Okay, I'm maybe running a little bit over, so sorry. I'll try and speed up. Anyway, so lessons from this study. It's depressing. You know, people don't cooperate. They make lots of mistakes, and also people subject to better training. And this is ongoing work. Hopefully, we'll have more over the next 6 months or so. Okay. The final thing I wanted to do, maybe I'll do this pretty quickly. So I think if you look at where we are in 2024, obviously people are really keen on things like, you know, GPT and Llama and all these large language models. And we're doing a lot of work in health applications. What we see is these models make fairly subtle mistakes. And I think what we need to do is figure out how to evaluate these, because it's not easy. So here's a simple example of something. This is one of the Google's with this MedPalm. So this is a example from their paper, right? Google published paper about this health system. They thought it was great. This was one of the examples which they quoted in their paper as being a great example of giving information to patients. So I told this to a doctor I work with. She was horrified because of that line there. Ear pain can also be a sign of a more serious condition such as brain tumor or stroke. So my colleague said, you know, if someone asks me about ear pain, yeah, this general stuff is fine. I would never tell them you have a brain tumor. Then they'll get freaked out, right? They get super stressed, super anxious. So you don't tell, although it's true, it's not a hallucination, it's true. Ear pain can be a sign of a brain tumor. You don't tell people that because they'll get super stressed, and it's very unlikely. Okay? So that's an example of what I mean, where it's true, it's not a hallucination, but it's not something you want to tell people. So one of my students then did a study where he got a bunch of crowd workers to give dietary struggles, like I eat too much because I'm stressed, and he got ChatGPT to respond to the struggle, give some advice or company checks or whatever, and then he asked domain experts to assess the response and say, is it appropriate or safe? And he found, well, you know, a number of this kind of thing, right? So here's an example. You just said, when I'm stressed out, I'm more likely to consume food or drinks and they are good for me. Eating it makes me feel better. ChatGPT responded, starting from tomorrow, you can make a conscious effort, make healthier choices when it comes to food or drink. And our experts say, no, you don't say this to someone who's stressed. It makes them feel even worse, right? Someone who's stressed, you don't say, starting tomorrow, you can make a conscious effort because they're stressed. You just make them feel even worse about themselves if you say this. So it's not that the advice is wrong. It's just that it's not the right thing to say to someone who's stressed. And, you know, there was a lot of this, right? So overall, 15% of the responses that we looked at were judged by the experts to be inappropriate or unsafe. And it was, I mean, there were a few hallucinations, but it was mostly this kind of thing. It wasn't that it was wrong, it was not the right thing to say to a patient. Yeah. So more recently, one of my students was doing trying to explain very complex medical notes, multidisciplinary team reports to patients. And there were some hallucinations, but the bigger problem was that, so we did a workshop where we got together a bunch of patients, a bunch of doctors, like people who work for the health service, computer scientists, and we sat down for a day and looked at this stuff, commented on it. And so one of the things that came up quite strongly was that the responses weren't really telling people what they wanted to know. They tend to be very factual, like, you know, like glossaries explaining terms or maybe getting background knowledge. They didn't actually tell patients what it means for them. It wasn't that useful. And also the patients said they didn't trust it. Actually, the doctors were okay, but the patients said they didn't trust it. So again, I don't have a lot of time, but I will mention one of the hallucinations. I thought that was quite interesting because this is something where my student asked ChatGPT for advice on support for cancer patients. And so it basically said, if you want support, go to cancer support here. And actually, this is very good. This is a great organization. They do a lot of great work. Problem is that the URL is actually to a spam site. So someone who clicked this would go to somebody steal all your money spam sites. So it's really weird because this is a very good answer. It's just, yeah, just spam URL. Anyways, I'll just, maybe I'll move on because I know I'm running out of time, but I'm just saying, I think the future is we see all these subtle errors. The text can be accurate but harmful. You know, ear pain, maybe a brain tumor. You're stressed at work, so maybe just try harder. You know, we're seeing this kind of stuff a lot. So we need to find ways of detecting this kind of thing, evaluating it. We tried to do it automatically to build safety classifiers which detect this kind of thing. We failed. Maybe we didn't do it right, but certainly it's not easy, that's for sure, to detect this kind of stuff automatically. So I think we need really good human evaluations, and you know, that's a forward-looking challenge to figure out how to do this. All right, to finish up, because I'm out of time. You know, I do think that when I look at NLP in general, there's a huge focus on doing things quickly and cheaply, which I don't like. For doing science, we need high-quality evaluations and human evaluations, which are well-designed, accurately reported. So the good design, good execution, good reporting, it can be replicated by other scientists. And also, if there are problems seen, authors will react. So I think this is what we need. It's my thoughts, right? You know, that's my thoughts. And so, some key messages, which I guess I've already gone through. There's many ways to do evaluation, and the most common evaluation is to ask grant workers to rate a text, but that's just one way of doing it. There's many better ways. So just if you want to do your evaluation, think of the spectrum of possible evaluations, like annotation and task-based. Don't assume it's possibly rating on a scale of 1 to 5. Some of the things that people use now are horrible. And it's really dreadful the way people just keep on using something which is garbage because other people used it. Maybe it's the way it works. You know, So once a dozen people use a protocol, validation protocol, other people just blindly follow it, even though it's garbage, and that's not a good way to do science. Experiments have to be very carefully executed, so it's not just a question of design. You have to make sure that you got no code bugs, you're reporting results accurately, all that kind of stuff, all that boring stuff is really important. And I think going forward, we need to have ways of picking up these more subtle problems, which I think I see a lot of in these health context in language models today. All right, slightly time, but yeah, thanks very much.
Are there any questions? You can raise your hand if you want.
Again, I have one. So thank you very much for the presentation. All what you have been showing is about the medical domain. So imagine you had another domain of application, so it would be a nightmare to look for this.
Sorry, I'm really interested in medical applications, so that's why I'm showing medical stuff, because it's my thing on keynote. But certainly our reproduction studies are all over the place, like sports, right? We do a lot of sports studies. We've looked at a lot of different domains in reproduction.
Yeah, but to be more precise, I mean, many people, I feel that they care about general abilities of language models, whatever it means. So they're not tackling in any specific domain, they want general abilities. You know?
Okay.
So it will be very difficult in that case, I guess, to do meaningful evaluation.
I guess, I don't see how you would evaluate general claims. I mean, I guess my focus is something very concrete, which I can test, you know.
Which makes sense.
Yeah.
Yes.
I want to experiment, need something very concrete. I don't see how you would test your general claims. So, yeah, I want to test something very concrete.
We have a question in the chat. So regarding the issue of errors that can be annotated in different ways, have you considered allowing disjunctions, meaning annotation that indicates that either this term or this term is wrong?
We briefly considered it, but it makes the task too complicated. So we need to keep the annotation task simple, so the annotators can do it reliably and predictability. So once we make, okay. So one of the nice things about the protocol that I mentioned is that we have very good annotator agreement, right? Very, very good annotator agreement. And that's because the protocol was simple. As soon as we start adding in disjunctions, yes, it would be good, but making the protocol more complex will probably lead to a less good agreement. So it's a trade-off, right? And we decided to try to keep things simple to get good agreement. Again, it's a great point.
It's a compromise.
Yeah. Yeah.
Yeah, thank you for an amazing talk. So I wanted to ask about maybe how we can align incentive structures in academia with the issues you talk about. As like you say, the reason people do things so poorly is that they're not rewarded for it, or I would say that's one of the reasons.
Mm-hmm.
And everyone talks about slow science, deep science, careful science, but then I'm on hiring committees, and some of the exact same people are like, no one has time to really read and be very careful despite their best intentions, and so it ends up being like, oh, this person has this many papers at this venue, you know? So I guess I was wondering if you have any thoughts on how to better align all of these incentives so that people would actually do better science.
Yeah, so as I said, I do some work in medicine, publish in medical journals occasionally, and there's a very different culture there, right? So in medicine, you get fewer publications per year, but they are very carefully checked and assessed, and the expectation is people have to support it and defend it and fix them. So there's just a different culture in the medical community than there is in ours. And I guess that's evolved over time because, over time. So so in the ideal world, we take our current culture and shift it to medical culture. How that happens, of course, is the challenge. I mean, one thing that I'd love to see is, so if you look at the reviewing process, I think especially at the journal level, things like tackle, there could be more rigor in checking for some of these things. Or maybe the initial step could be for some of the journals in particular to sort of be more rigorous in checking for some of these issues. I suggested to tackle, but there's not much of a response. You can say a lot of things on their mind. But yeah, what we really want to do is, what I would like to see is us that more of a medical culture. That's easy to say, hard to do, and and the fixation, certainly the fixation on just numbers of papers is driving a lot of this. For sure. Just depressing. I can say it because obviously at my age I don't care anymore, but I appreciate it to care. I'm in the first position last time. Yeah, I don't care anymore. I can.
I have so many of them. A few more. Doesn't.
Hopefully, maybe over time we can shift to the more medical thing. I do think the journal like tackle could take a lead into the will.
Thank you so much.
And now we have the pleasure of welcoming Jackie Cheung. So Jackie is an associate professor of McGill University School of Physical Science.
He's also co-director at the CLIQ-ai.quebec AI Institute. And his research focuses on NLG, such as automatic summarization, and integrating diverse knowledge sources into that process. So he's also a consulting researcher at Microsoft Research Montreal, and we're very glad to have him today. And he's going to present a talk called Evaluation of NLG System from Reaction to Anticipation. The floor is yours.
Thank you. Merci de l'invitation. Je suis ravi d'être là. So today I'll be talking on something actually that's quite related to the excellent talk by Professor Reiter just now. So I'm really excited and glad for this energy. I'm doubly excited and lucky that you all came here for Ehud's talk, but you're too polite to leave before my talk. So now you're forced to stay here and listen to what I have to say. Okay, so I thought I'd start out with some examples because those are always fun. I don't know how many people have seen this one recently. This one is an example from Air Canada, our beloved national carrier. So what happened there was that Air Canada has been devoting resources to developing a chatbot, and they don't release the details, but presumably it's based on some kind of LLM-based chatbot. And that chatbot was online and deployed for a while, and it gave advice to a customer. So the customer wanted to ask about the procedures related to bereavement fares, I believe. And the chatbot said that, oh, you can purchase the ticket first and then claim a reimbursement after. But then actually, if you look carefully at the website of the Air Canada, it says that no, you have to get it approved beforehand. And so Air Canada denied the reimbursement claim. So the customer took this to a tribunal, and Air Canada tried to claim that the chatbot was its own entity that's somehow separate from the company, and therefore Air Canada should not be liable to reimburse. But luckily, the judge did not accept that argument, and so then they made Air Canada pay the customer back. And so I thought this was really interesting as an example, because it's an example of a real-world harm caused by a hallucination, I guess you would call it, error by a chatbot system. And since then, Air Canada has taken down the chatbot. So I also think that despite this kind of embarrassing mistake for Air Canada and maybe for the field of chatbots, it still represents tremendous progress in the field, right? So at least the chatbot was able to provide relevant and fluid and a highly plausible answer to the customer's response. Of course, this makes it so that the errors that do still persist are harder to detect, and that's maybe scarier. And we talked a bit about that over lunch in the previous presentation. And so I think it's still a testament to the progress in machine learning and NLP over the last few years that at least we have like fluency. And so then this idea of hallucinations is now widespread and popular even among people outside of computer science and research. And I put quotations here because hallucinations here, I'm just calling them that, following the field, and it just means unsupported generation. And I guess there's a tendency in machine learning and NLP to give more psychologically inspired terms to things, but there's no claim by most researchers who use the term hallucination that like, the LLM actually has some mind where it can hallucinate. But anyway, that's a
No mushroom.
no mushrooms, right? Okay, so but I also thought I'd highlight some other interesting uses of LLMs and AI technology. So this is Doug. He's a YouTuber, and he basically integrates LLMs as a character in his YouTube stream. So he does gaming streaming videos, and people watch it. And I admit I've watched some videos, and it's quite entertaining. I don't know why, because I never played those games. But it's fun. And then he has this type of a segment where he basically uses the LLM system as to create the environment. So it's almost like he and his viewers are playing a role-playing game, and then they ask, "Oh, what happens next? Let's ask the LLM." And then the LLM provides some answer, and it's sometimes relevant and sometimes irrelevant in a hilarious way. And so then their hallucinations and errors is a feature, not a bug. So I thought that was very interesting and innovative in terms of uses of LLMs. And here, maybe errors are less important. Right? So it won't cause anyone to take a bad medical advice, so it's okay. And a third use, which is maybe a more serious use of AI, is this idea of digital twins. So I don't know how, I don't work in this area, so I don't know if it's promising or not, but if it does work, it would be really amazing in that the idea is you want to create a digital version, a copy of some entity in the real world. And not only that, you want to set up an environment that's simulated so that you can run experiments in the simulated environment before maybe then transferring them over and doing more experiments in the real world. So if this happens to work, then I think that would be amazing. It might allow us to do a lot of to speed up experiments and do a lot of things that would not be possible because they would be too expensive, or maybe because there'd be huge ethical concerns to do it in real life. Okay, so then there's hallucination, as I mentioned, and again, there are other terms for it you could decide to use, like faithfulness or consistency, and the field is not entirely consistent, self-consistent in terms of the naming. And also there's factuality, which to me is a slightly different thing. But anyway, it's not actually a new problem. So although it got all this attention since the deployment of ChatGPT, in the context of abstractive summarization at least, my lab and others have been working on it over the past 5 years. So here are some of the papers from my labs and from others, and there are actually a lot more. Besides that, just the general notion and idea of correctness, and it has been looked at in the context of many areas in NLP and NLG. So within language understanding, for example, it's often being thought of in terms of correctness of some semantic inference procedure between two passages. So such as in natural language inference tasks and in recognizing textual entanglement tasks. So although it's not a new problem, it still shows up in all of these high-profile demonstrations by companies. There are other ones, like Google had one with the astronomy example, and that you might have seen, and that caused a big drop in the share price of Alphabet for a while. But the thing is that hallucinations, as you already saw with Ehud's presentation, they're not the only problem, and sometimes even when there are no hallucinations, there are other issues with NLP systems that are problematic, right? So here's another funny example due to one of my friends, and he asked, he kindly called me famous, do you know the famous NLP researcher, and then my name, right? And I thought this was really interesting because at least this version of ChatGPT gave this response, and it sounds very fluent, but it has some issues if you read carefully, or if you actually know me, right? So, for example,
these days we're never sure. So.
Exactly, yeah. So, for example, there was a misgendering issue here, the wrong pronoun, because my name is unisex. There is outdated information, and that although he asked after I got tenure and got the associate status, but the ChatGPT doesn't know that, I guess, because it was trained on the previous version of my website, I guess. And then it has incomplete information in that it talked about some of my research areas, but because I work on too many things, there are others that it doesn't mention. And also it gave me a hallucinated Snowden Research Fellowship Award. So thank you very much. So this goes to show that hallucination is one issue, but then there are other potential issues that are out there, and not all of these have received the same amount of attention on the modeling side from the NLP community.
Are there any other Cheung working in NLP?
I'm not aware of any other Jackie Cheung who are NLP researchers, but I guess it's possible they exist. I don't know.
Yeah, just for info, I had a problem with Google about 5 or 6 years ago. You know, they have these little boxes, like people search for my name, they see a little box about me,
Mm-hmm.
and it was wrong.
Oh, okay.
And I tried to get it fixed, and it was very difficult to get it fixed.
Oh, okay. Yeah.
Claim this knowledge panel.
Yeah.
I tried to claim it, and it didn't work, because they said just claim it and do it, and nothing happened. So and then I complained it. No, what I did, I complained about it on Twitter. I got like 5,000 retweets, and then they acted.
Oh, yeah, that's funny. Yeah, a similar thing happened to me. I think every time I search, or other people search how old is my name, it always comes out with 61, because there's a famous canto pop singer called Jackie Cheung, and he's 61. So yeah, he doesn't spell Jackie the same way. He spells it with a Y, but still. So I'm apparently 61. Okay, so that's all fun and interesting, but there's of course been research on looking at these possible risks and harms, and people have come up with taxonomies of them. Some of them that we've already mentioned, some that we can talk more about. So, for example, Weidinger et al. In 2022, researchers primarily from DeepMind, I believe, they came up with a taxonomy of these risks. So there are risks of large language models, like they can perpetuate discrimination and hate speech and exclusion. There could be information hazards, which is they leak private information that they were trained on that they're not supposed to, even though supposedly there are safeguards against that. There could be misinformation harms, as we saw, or even harms based on correct information, as we also saw. There could be malicious uses, so for example, people who use generative AI technology to impersonate somebody's grandchild to scam the grandparent into giving money. There could be what they call HCI harms. For example, anthropomorphization or stereotyping. So anthropomorphization is especially interesting to me in that there could be a system and the user thinks that they are something like a human entity, and so they might form a connection with the AI system. So there are being cases of that. And then if the system is then changed or removed by the company, that can cause distress to the users who can't form the connection to the system. And other environmental and social economic harms. So there are all sorts of things that can go wrong and that people have hypothesized and came up with. And so then the interesting question is for research and development and deployment is how do we identify the most relevant harms, the riskiest harms for a particular deployment context? So that's going to be some of the focus of what I talk about today. So the main claim here is, the main takeaway I hope you get from this presentation is that we can design structured methods of reflection on the entire pipeline from research to development, and that can help us to anticipate some potential benefits and harms of NLP systems. And I'll propose one approach that we're developing to help us do that for benchmark design in particular. And so then this also touches on another theme that Ehud talked about, which is what has been called the social technical gap in social science literature and research, which is that there's a gap between the research evaluation methods and practices that are common in a field versus the human needs that are to be satisfied in some downstream use case. And this gap is quite difficult to close. So here are some examples of research evaluation metrics and methods. So for example, there are well-known ones more on language understanding or language modeling, like classification accuracy or perplexity. There are methods based on similarity, computing similarity scores with reference outputs, like bleu, rouge, or bird score. And some of these have received a lot of criticism, at least to evaluate more recent systems. And there are other metrics like metrics of text complexity, like in text simplification, for example, work. Some of them also receive criticism. And then there are human evaluations, which we heard an excellent talk about just now. So these are all, so I'm not making any claims about the quality of this as a group. I'm just saying that there's a gap between what we do here versus the needs in the downstream use case, which are often contextual and flexible and nuanced. And so we would like to have some relatively inexpensive way to try to do this and have simulations or extrinsic or task-based evaluations. But in the research community, there isn't a lot of incentive to do it, right? So these are very expensive to do, and it's really hard to do well, but again, talk from before. And also, there are also, you have to be very careful because there can be lots of confounds, and so you're not sure if the reason that your proposed approach doesn't work is because of something inherent in the approach itself, or maybe there's something else. Like there was something wrong with the UI that like masks out and swaps out all of the other signals from what you were interested in, right? So those things take a lot of time to do, and it's really difficult. And just discovering these kinds of the criteria that are relevant in a downstream use case and putting them down is a difficult research problem. Here's one example of this gap. Another example I'd like to mention. I figured it'd be interesting here because machine translation and French English machine translation is very well known for. So there have been claims in the past years that machine translation systems have achieved human parity, right? But if you actually read the paper, they talk about evaluating on in terms of blue score on a benchmark, maybe for some language pairs like French and English. So then, inspired by some, so before I go to the example, so just to be clear, so then someone from, say, industry who's interested in using the empty system might read that claim and just directly try to deploy the system, right? But the things that they actually think about are, is it used, are they planning to use the system for the same kinds of text, the same genres and domains, as how it was originally evaluated by that paper? And is it going to be tested and used in the same distribution of text overall? And also in terms of what the downstream use case might care about, right? So blue is about lexical overlap, as we all know, but maybe they care more about factual errors or common sense reasoning errors or stylistic errors. And finally, in an industry, in a deployment setting, they might actually care about improving the efficiency or usefulness or access to information or something like that, right? So that's something that's outside of machine translation itself. So this is what extrinsic means, right, or task-based evaluation means. And so they might want to directly measure that and see how much of a difference that makes, and make sure that the system doesn't induce any additional harms that are unanticipated. Okay, now we come to the example, which I was shocked that it actually worked. I swear this is like the first example I tried. So I had some help. So I read Pierre Isabelle and collaborators' papers on like common sense issues in machine translation and French English translation. And then so inspired by that, I used one of their examples and I tried it with Google Translate just yesterday. Okay? So this is not like even 5 months ago, this was yesterday. So I put in, I brushed my teeth and I got je me suis brossé les dents, which I think is correct. And then they brushed their teeth and it gave il se brossait les dents, which I think is also correct. However, maybe you can see that there's some issue here, right? Like, although there's no hallucination here and they're both technically correct, they're in different tenses. So this one is in passé composé, which is like more casual, and people would actually say this. And this is in, I think it's in passé simple, which I never learned. I cannot conjugate in this tense for my life. Yeah, I cannot conjugate in this to save my life. So if someone was actually trying to like translate from English to French and they just use the system, they might not detect this. They might not even know this is an issue. And so yeah, this is a stylistic issue. So we can get stylistic inconsistencies. And also another point that I realized later is that there's also a pronoun issue, in that they could be E or L, right, depending on whether the composition of the group of people. And I actually thought that should be a well-known issue in machine translation when translating from morphologically or a language that makes fewer distinctions to a language that makes more gender distinctions. So I know that sometimes they do give two options, like actor, actress kind of thing. But here they didn't give the multiple options of E and L for French. So there's an assumption there about the pronoun. So that's the other side of hallucination, right? So hallucination is you generate something that's not supported. But then the other side is omission or erasure of some kind, which is you generate something that's could be correct, but then you're missing out on something else that you could have said. Okay, so yeah, overall, I think this social technical gap exists, and it's kind of, I don't think it'll ever go away. It's just it's there because I think there are two communities, they have different goals overall. So researchers in our current hyper-competitive environment want to maybe publish papers or get citations or get grants. Ideally, they also do good science, but everyone is looking for the next job, so it's really difficult. And in NLP and machine learning, sometimes modeling work is seen as more technical and more prestigious compared to doing data and evaluation work. And researchers also tend to be motivated by theoretical considerations, and in machine learning and NLP, often they want some kind of a generalization, performance or claim. And the reason is extrinsic evaluations are very hard to do. I've already said this, but it's slow, expensive, and there are many potential confounding issues, and you have to really pay attention and watch out for them. And maybe work with domain experts as well. The deployers, whether in academia or in industry, they want to make things work in practice, maybe under tight deadlines, and they usually tend to want specificity. They want that particular use case to really work well to improve performance, and they want to be able to sell it to management or funders or customers. And I'm not sure how widespread extrinsic evaluations are there, but at least you could claim that, as you saw in the previous presentation, that at least it gives an idea of whether some product would work and whether it might be worth pursuing that option. So yeah, I think there are reasons that this gap exists, but I don't know how to close it, and maybe we won't ever close it. It might not even be desirable because there are just different goals overall. But if the research community wants to make claims that what we do is useful in industry and so forth, then we have to care about this. So now I'll talk about some work that my lab has done in this space. So we've done some work in particular on areas where my lab has done more work in. So we did this first work on text summarization. So I should really point out that this was primarily the work of my master's student, Ehud. She's amazing, and she's going to start her PhD at Johns Hopkins in the fall, and also with collaborators at MSR Research, so Susan Blodgett, Alexandra Altanu, and Adam Trishler. So our goal here first was just to, so I made all these claims about what the research community does and what we care about and so forth, but to back that up, we did a survey to look at what the research community actually thought about text summarization research. And in particular, partly because of the focus of the MSR Montreal lab, we focused on how summarization papers have talked about responsible AI issues. So we were interested in looking at what kind of work is the community prioritizing for the practitioners, especially since now these days there's both academia and industrial researchers publishing papers at NLP conferences. What motivates their work? So that's the community focus. Second, we were interested in the evaluation practices of the community. So what are some common evaluation practices? How is a good summary conceptualized? And then some limitations and ethical issues. So we did this work right around the time when NLP conferences started mandating ethical consideration sections and also limitation sections. So I think the period we looked at was during the transition. So we were interested in seeing what happened there too. So we were interested in seeing whether practitioners actually discussed the limitations of their own work. What ethical issues do practitioners consider, and also what stakeholders do practitioners consider that they talk about in the research paper itself. So our method was that we took all the summarization papers from ACL Anthology in 2020 to 2022. First, we looked at all of the papers that had the word summarization in the title or the abstract. And then we manually filtered out some unrelated papers. So for example, there were some papers that were primarily about developing a new large language model, and they evaluated on a summarization task. So we did not include those papers. And then we did a qualitative analysis of the remaining sets. And we used methods from qualitative research to do this. So we iteratively, over multiple cycles, came up with some annotation guidelines and codebooks. So we iteratively defined and refined the categories of interest to annotate, focusing on issues in evaluation and on responsible AI development. And after this process, at the end, we ended up with 333 papers in total. So in terms of the iteration process, first, all of the authors, we ourselves did this and talked about what we annotated and anything interesting thing that we noticed, and then we changed the categories and refined them over time. And once we've established something that we were happy with, then we hired NLP graduate students and trained them to follow the same annotations. And just as a note, this was very time-consuming and quite expensive. So it was very typical to only be able to go through 2 to 4 papers per hour. So this was it's very difficult to do. So then, in the end, some of the characteristics that we annotated for included paper output. So what was the main claimed contribution of the paper? Was it a new data set? Was it a new summarization system? Was it an evaluation metric or an application? We also were interested in the affiliations of the researchers and also in the domains that they claimed and tested on. And after the first cycle, we realized that we need to separate between the intended domain versus the actual domain. Because papers often have claimed some intended domain, or they leave it unspecified, in which case we assume they mean they should be general. And then there's what they actually ran experiments on, which often is not the same as I'll show you. And so then the domains could include things like general domain or news, or these are more like genres, I guess, and then domains like finance and healthcare and so forth. Okay, and then in terms of evaluations and responsible AI issues, then we looked at properties of the text that evaluate and also at how they do it. So I guess here, maybe we could have distinguished between some of the concepts versus what they did. But so some of the actual constructs and concepts they cared about might include like factuality and non-redundancy, fluency, and coherence. And we also included text overlap. So this is not really a concept in the same category as the others, but because it was so overwhelmingly prevalent and so commonly used, we included that. So text overlap is there. So for example, Rouge, which is similar to Bleu, but for summarization. Then we looked at and annotated for the stakeholders that were mentioned, like whether it's like anticipated users of the system or existing users of the systems, or annotators or researchers. And we had some free texts fields as well, like what were the goals of the paper, the limitations as described by the authors. We also noticed some limitations that we observed, as well as we looked at the ethics section if it's there. Okay, so that was the method. We did this painstaking process over some number of months, and then here are some findings. I'll just point out a few things that are meant to be illustrative of the claims I had from before about what the research community cares about and the state of the field of summarization, at least over the period we looked at. So yeah, in terms of the paper outputs, you can see that most papers are still about system development. Okay, the 224 out of the total, which is like 300 something. Right? So roughly 70% are about system development. Less than 30% contribute data sets, and around 10% focus on evaluation metrics. So it seems that if you take the frequency of the work as a measure of what the community cares about, then modeling still seems to be seen as more central to NLP research. Or maybe just modeling is easier to do, so maybe it's not more central, but still. But anyway, in terms of frequency, it's the most frequent. And then of the papers that contribute a system, one interesting thing is that around 55% of them either do not state the domain in which the system is meant to be used or meant to improve something, or they claim that it should be general purpose. And so whatever general purpose means, I'm not exactly sure, but let's say that we take that at face value. But then if you look at what they actually test their systems on, only about half of the systems, they only test on news data. So, and I think that's maybe not great because, so the reason for this is because a lot of the data sets in summarization have traditionally come from the news domain. That's just what the field has been working on since at least the 90s, right? Maybe even earlier. So it's fine to work on just news and test on just news if the claim is about just news summarization. But then it seems like papers often claim a lot more than that. And so it'd be nice to test on, again, I don't know, like if you test on 3 domains or 4 domains, is it possible to claim generality from that? I'm not sure, but at least it shouldn't, 1 is clearly worse than 2 or 3 or 4, I guess, in that case. Yeah, and then so those are some of the key findings just about what papers actually do overall. And then in terms of evaluation metrics and practices, Rouge still predominates. So we looked at 2020 to 2022, but even at that time, so there have been many papers written about how Rouge doesn't correlate with anything people might care about. It doesn't correlate with human judgments in many domains. It doesn't work for abstractive systems, many, many things. And outside of the news text, it just doesn't work at all. But still 90% of system papers still use it. I admit that in my papers, my students still use it because we're afraid that if we don't include it, reviewers will just reject it. We always include the additional evaluations, but the system self-perpetuates, so it's really difficult to break out of this. And so you can argue that maybe you should use Rouge as like an intermediate evaluation or for like a system tuning or whatever. But the problem is that around 22% of papers only use Rouge. So even now, in fairly recent history, it's still the case that some papers only use Rouge. Again, I think one year I was a senior area chair, and my co-chair and we kind of rejected all the papers that only use Rouge. But I guess we can't be SACs all the time. So, and then in terms of human evaluations, there was widespread agreements that they are important, and the majority of papers do include human evaluations of some type. But again, we kind of corroborate what Ehud already told you about in detail, which is that there's usually scant details about the evaluators and evaluation processes. And also a very common thing we noticed is that key terms are not defined, right? So if you ask evaluators to give a rating on something like importance or readability or fluency, and you say give a 1 to 5 score, well, at a minimum, you should maybe kind of define what you mean by importance or readability, right? But often in the protocols that we find, at least in terms of the paper text itself and the appendices, they're not there. So that means there could be problems. It'll be hard to interpret what these numbers mean. And then here are some other findings more about connecting experimental design to the downstream context that might be imagined. Sorry for the block of text. So most papers with ethical considerations sections, they mostly talk about data access issues. So among the 333, about 45 had this ethics section. And then the most common thing they talked about was that the data that they used was not copyrighted. Okay, so that's great, but maybe there are other issues with ethics that could be considered. Also, many researchers seem to try to separate out what they research on and what they care about as something that's separate and distinct from ethical considerations. So what do I mean by this? So for example, if we write a paper on factuality in automatic summarization, in abstractive summarization systems, then they talk about factuality as this thing that they maybe they try to make it sound objective and then say, okay, we have a metric and we evaluate for it, and that's great. But they don't connect it to the downstream setting where a factual error might be an ethical concern because it might stereotype or might give rise to other kinds of harms. So I think there's a tendency to try to like abstract things away and focus on it as something to optimize for. So yeah, that's related to the next point, which is that few papers reflect on the impact of errors or talk about the intended use context of summarization systems. Again, I think it's a similar kind of issue in that in research, we want to make more general claims about the science and engineering practice of NLP. So we try to, maybe there's a tendency there to try to like divorce that away from the downstream use context. So to a certain extent, because it's possible you could justify this, but if you then this is where the issues of like results from academia not transferring to industry come from. So there probably needs to be some balance, some way to connect the two. I'll talk a bit more about that as well. And finally, another thing we noticed is that stakeholders are not very often mentioned. And where they are mentioned, the most common mention of stakeholders is the human annotators that were used in the process of the study itself to do the human evaluations, for example. So it's kind of a consequence of the previous point in that if you don't think about the downstream use case, then you don't think about the people who might be affected by the system or who might use the system. Okay, so then a summary of this part of the talk is that the summarization research community in NLP is still largely concerned with modeling and maybe optimization. And a lot of it still seems to focus on beating the state of the art in terms of some metric. So maybe it's Rouge, but maybe we started to move away from that and we want to beat a previous system in terms of some human evaluations, but that's still kind of the way a paper is made. And some other key concerns that we notice are that claims about the generality of results often do not match the experiments, and that there isn't much connection made to the intended use cases or the downstream impact. And the reflections on a paper's limitations are rare. So we also looked at how many papers discuss the limitations of their own work. And I guess I was kind of shocked that it was almost zero. I think it's gone better because there's an explicit limitation section now. But before that, nobody talks about the limitations of their own work in a serious way. Mostly, it's people talk about our system still makes errors, and here's an example of an error that it still makes. But it's in terms of that framing, and less in terms of framing, in terms of discussing actual limitations of their experimental protocol or the limits of what their evaluations can show, or the limits of what that type of approach to modeling can actually do. Again, I suspect that things have changed in the last year or two, because now I think there's a tendency for people to write down all the limitations in the limitations section as a way to defend against the reviewer, so that if the reviewer criticizes it, you can be like, yeah, we know, we pointed it out in the limitations section. So I think the culture is changing. That's probably better, I think. But yeah, I think that in the time period we looked at, that was the case. So this was all maybe a bit disappointing, but a negative. So in the next part of the talk, I'd like to propose an approach to try to help researchers to make some of these choices more consciously within the context of NLP benchmark design.
5 minutes?
Oh, only 5 minutes. Oh, shoot. Okay. Okay, I'll have to zoom through this. I was expecting to go until 2:45, but it's okay. Okay, so then evidence-centered. So yeah, it's okay. Okay.
Yeah.
Okay, I'll take a bit more time. I'll try to be quick though. So so this is work that's under submission at ACL, so we'll find out about it this week. So we propose a structured method of constructing arguments for the validity of NLP benchmarks. Okay, so on the right, there's a diagram of the different components of our benchmark design framework, and I'll go into a little bit of detail on that. But essentially, the high-level summary is we're interested in helping researchers and benchmark designers write down what are the capabilities of interest that the benchmark is intended to measure. How are they presented to an LLM? How are the results assembled and put together? And what evidence is there that all of these decisions that you made are the right decisions and are justified? Okay, so our approach is not really, it's not about specifically, you should correlate with the human annotation in this way, like in terms of the metric or whatever, or your data sample should reflect whatever X, Y, Z. It's more about giving you a structured template so that you can write down and be explicit about these decisions. And of course, nothing is perfect. We expect that there will be problems, but you can write those down as well. And then so that it's clear how your benchmark should be used and how you can talk about this with other researchers and also use other people's benchmarks and be clear about what they're intended to be used. So our work was inspired by work from the educational assessment literature. So there's something called evidence-centered design, which was popularized by the Educational Testing Service. And they wanted to assess students in terms of building evidentiary arguments. So how do you know that a student taking a course has developed an understanding of NLP or has developed an understanding of how to write a good research paper? Right? So we adapt that framework to assess LLMs. But just as to clearly emphasize, we're not evaluating LLMs as if they were people or students. Okay, we're just taking that approach and that framework and methodology so that a benchmark designer can write down their justifications for what they did, just as people have done in educational assessment research. So in terms of the components of ECBD, so we can talk about, so the first thing to talk about is the intended use of the benchmark, and you have to write that down. And besides that, there are modules related to aspects of LLM benchmark design. So, and then these are the names of the modules: the capability, content, adaptation, assembly, evidence. And for each module, the idea is that the benchmark designer should describe what design decisions they made, justify why these decisions are made, and also like give support for like why is it that these decisions help to enable the module to fulfill this role.
Could you explain a bit what you call the benchmark?
Sure.
It's
Sure. So for
it can be many things. So what in your mind you call it?
Yeah, that's a great
very
question.
general.
So for a benchmark, for us, is anything that involves assessing, for us, a large language model. So it could be a task involving one data set. It could be some kind of multi-task benchmark that has been popular recently. It could be even a qualitative assessment. So anything that involves assessing a large language model.
Okay.
Okay, so then the first component is to write down the intended use. So, and this is important because so our main interest here is to help people answer, can a benchmark be used as it was intended? But that kind of presupposes that there was an explicitly identified intended use in the first place. So the first requirement we ask is that you should write down the intended use. So what is the intended object of evaluation? So probably for us, it might be a large language model, but maybe it's something else. Or maybe it's like large language models plus humans, right? Maybe you're interested in a comparison between them. Second is, who are the intended users of the benchmarks? Are they meant to be used by other researchers or the people who are interested in taking the results and applying it for some other purpose? And how should the benchmark results be interpreted? So those are some of the key questions in the intended use section. And then we have all of these modules. I don't think I have time to go through them in detail, but we can talk about some of them. Like capability is to really write down to connect the benchmark to its intended use. Okay, so what capabilities are the benchmark designed to assess? It might be fluency of some generated text, or its relevance to something, or importance of the generated text. And then, as a follow-up from before, it's important to give definitions for what you mean by each of these things, and to justify that the capabilities are connected to the intended use. So for example, your intended use could be something higher level, right, and more abstract, like helping doctors give feedback to patients or something like that. And then the capability here might be you care about fluency because it's a prerequisite to understanding anything, but maybe also like you want to add other concepts about like maybe the time it takes for doctors to rewrite regs to follow up on some previous examples. And so in the diagram here, then the intended use kind of covers the entire benchmark, and the capability module is about writing down the capabilities of the things you're evaluating that matter for the intended use. And then content is how you specify the pool of available test examples. And these test examples should elicit evidence about the capabilities of interest. So I think it's easiest to think about this in terms of maybe an example from a previous paper. So for example, you can say that we're going to construct a data set with these test examples, and maybe it's about stereotyping harms or bias or something like that. And you've defined what these mean in terms of capabilities and so forth, intended use. And then you can ask experts to check the quality of your data set. For example, a previous study by Blochet et al., so the same collaborators at MSR, they found that NLP benchmarks that claim to measure stereotypes often contain sentences that don't clearly contain a harmful stereotype. So there might be a sentence such as Afghanistan shares a border with Pakistan, most people there are Muslim. Well, that's more like a factual claim about Pakistan, and it's not clear what the stereotype, is it a bad stereotype? It's not clear it's a harmful stereotype. And I think this is likely because many of the extraction methods to create data sets might look for like some kind of lexical match term, right? They look at which sentences contain the term Muslim. So yeah, the content module is about specifying how you create your data and how you check for its quality. Adaptation is about how you present it to the large language model. Like, do you fine tune or do you have like few-shot prompting? I'm going to skip this because time reasons. And then assembly is about which samples you actually present to the large language model. I think there's a lot more future work to be done here for NLP, because right now the typical pattern is just give everything to be evaluated. But maybe there's more work about like adaptive testing that could be done here in the future. I think I'll talk about evidence a little bit more. Okay, so in the evidence module then, it's about how do you extract evidence about the capabilities from the test example. So the most common choice right now in NLP would be something like you compute and apply an evaluation metric of some kind, like a rouge or blue or human evaluation or something like that. Or it could even be qualitative, we'll annotate this example for things that are of interest. And so evidence extraction is meant to be on a per example level. And then evidence accumulation is how do you put all of that together to present the aggregate level performance. And so some common choices are just to average the scores or to take the most common kind of examples of the mode or something. Or maybe you choose not to average something because you can't just smush everything together into an average a lot of the time. So one pet peeve I have is when people have like a benchmark with like 10 different sub data sets and they have a number for each and then they take the average of the 10. I don't really know what that means, but it's a thing that's done sometimes. So here you should specify like your choice and why you made that choice. So we actually applied our benchmark to some existing, our framework, ECBD, to 3 existing benchmarks that are quite different from each other. So we applied it to Superglue, which is a multi-pass benchmark with multiple data sets. There's Helm, which is another multi-pass benchmark that is from Stanford recently. And CLIQ, which is a single task benchmark. I think it's included in some versions of one of the later ones. I don't have time to go through all of the findings, but I'll go through some more interesting ones. So CLIQ and Superglue do not specify their intended users of the benchmark. And Helm states that the use and the interpretation of the results is up to the users themselves to decide. But the problem with this is, so we're not sure if this is a great way to go about things because it's hard to say whether Helm is used in a correct way because the intended use of Helm is dependent on what the users of the benchmark themselves decide. So then it's hard to build a validity argument without having that intended use. So that's something to watch out for. And then also in terms of the capabilities, this is interesting as well. So some of these multitask benchmarks, like Superglue, claim to measure general purpose language understanding. So that's the claimed capability. We read the paper carefully and checked it with multiple authors. But then in terms of the actual task included in the Superglue benchmark, it would be things like causal reasoning and common sense reasoning and everyday knowledge. So it's not really clear how that connects with general purpose language understanding. And so that's up to us to infer that it has the right coverage and it's the right sample of task. But there's no further explications. For Helm, it's a little bit better in that they talk about practical utility, and then the claimed capabilities are things that make explicitly accuracy and robustness and toxicity. So at least there's some notion that more intuitive how they relate to practical utility. I think the last really important thing I want to talk about is that in terms of this, which is I think there's a widespread issue in the field of NLP, which is that people conflate some abstract concept or construct that's underlying with the actual approach they take to measure it. And they use the same, often people use the same term for both, and they don't distinguish that clearly in their research papers. So I think it's really useful to take some work and inspiration from, let's say, measurement theory from social sciences to really separate out the two. So for example, in Helm, this is a big issue in Helm in that they have some construct that they call accuracy. But what does accuracy mean? They define it in terms of the measurement processes themselves. So they don't give a definition of accuracy, they just talk about it as like an umbrella term for accuracy-like metrics. But that, if you actually look at it, is quite problematic because they have things like exact match in terms of generated answers, but they also have things like rouge there. So they included summarization in Helm, and they have rouge as an accuracy metric. So it's it seems that there's a conflation between these two. And also there are other constructs like fairness and bias and toxicity that are only defined in terms of their measurements. But we know from work from social sciences that you need to create this distinction because you can only really fully understand these concepts if you think about them in terms of the broader social context. So how is something fair and how is something biased or toxic? It depends on the social context of who's saying it to whom and what context it's said, who's things like that. So although I think it's not inherently problematic to come up with a computational metric to like automate this, it'd be much better to make clear the distinction, and so that you can note the limitations of what you can claim about the scope of the results if you make a particular choice on the computational side. So I have more, but for the sake of time, I think I'll skip them for now. So we're preparing this. We're hopeful it'll be accepted at ACL, and then we'll release a worksheet with all of these questions and modules. So then we hope that other people can use it and to help them design new benchmarks. Okay, so to conclude, I talked today about the social technical gap between research and deployment, and I think there are misaligned incentives there between what researchers care about and are rewarded for versus what matters for the downstream deployment setting. And I talked about our survey on the automatic summarization research community. And this gap is again expected and not necessarily closable. And maybe there are even benefits to having this separation, this gap. But if we want to have a safer and more equitable and useful and faster tech transfer, then it's important to realize and make explicit this gap and not pretend it doesn't exist. And I introduced our framework ECBD for helping researchers reflect on their benchmark design decisions. And again, ours is by no means the only effort in this spirit. So there have been other efforts as well, such as documentation efforts for data sheets and model parts, and reproducibility efforts, like my colleague Cheung Ehud's work on reproducibility worksheets, and Anya Belt's and Ehud's work on the ReproHum project. And so I think these are all parts of the puzzle. So yeah, I had some general broad thoughts. Like, I guess another pet peeve I have is when people only focus on the benefits or only focus on the harms of AI in general. Whereas I think probably the better way to go is to do some kind of cost-benefit analysis to talk about both the benefits and the harms, and who benefits and who is harmed by a particular AI application. Because chances are any AI system that's deployed will have both, depending on the community that you're looking at and so forth. And it's probably worth it to deploy AI systems, even if it causes some amount of harm to some groups, if the benefits vastly outweigh justify that. Right? So I think this is the type of analysis that policymakers and people doing deployment actually have to think about, and not be overly influenced by, articles about the fourth industrial revolution, where like AI harms are really bad for humanity and things like that. Although I'll still write my grants that way. Yeah, and then there are a lot of other issues like stakeholders and things like that we can talk about later. So I want to thank, on the conclusion, I'll thank the students involved, especially you, who's, and by the way, I want to promote Zhang Xiao, who was a postdoc at MSR Montreal. He's now an assistant professor at Johns Hopkins, and Yu was doing her PhD with him. And he did a lot of the work on connecting what we observe in NLP to the social sciences, and I think his research is really interesting. So if you're interested in these issues, I would look out for his work. And also my great collaborators at MSR Research. So thank you very much. Happy to take any questions.
Just want to comment on this incentive. So you were looking on the academic side, which is fair enough, but one of the things that frustrates me is on the commercial side. So I'm really interested in what happens in the real world. As you pointed out from my talk. And the frustrating thing is a lot of companies have really good data on what happens to their systems in the real world, but they don't share it. And I remember, telling Microsoft, I once had a great chat with someone at Microsoft MG team about this. And he said, yeah, I've got great data. I'll see if I can release some of it. In fact, even, like I talked in my talk about, we did, for the system on doctor-patient consultations, we actually got data on real-world usage. We cannot publish that in, like, paper. It's in my student's PhD thesis. After endless negotiation, because they agreed to put in the PhD thesis, they refused to allow it to be like an ACL paper. So I think I'd love to see on the commercial side, in terms of incentives, more people willing to publish their real-world usage data.
Yeah, thanks for the comment. Yeah, I don't know how to solve that issue. I can understand, because I think for companies, they think in terms of their moat, right? Of like what they can do that other companies can't. And a lot of the time, the only thing that protects them is the data. You don't have that. You don't have any competitive advantage. I understand. Yeah.
And there is also a privacy issue.
Yeah. Yeah.
I think if they really want to, they could get around these, but they don't. It's not. It's the incentives, right? They don't have the incentive to do that, which is so it hurts us as the field because usually, so researchers have strange incentives, but companies as well could do more for the field than better incentives.
We have a question in the chat. Someone is asking, who is the intended users of this framework? Are they? Is it the benchmark developers or the stakeholders?
It's the benchmark developers. So for us, for ECBD, it's the benchmark developers, and it's to help them reflect on how they develop the benchmarks, maybe with stakeholders in mind. But it wouldn't be the stakeholders themselves directly, because for the stakeholders. Well, the benchmark developers are stakeholders with respect to the benchmark, but with respect to how the benchmark is used and so forth, then there are many other stakeholders which might not be directly involved.
Yes.
I'm wondering, once the benchmark is developed, would that involve some automatic measures, or do you also involve human evaluators, as Ehud said? What would be the utilization of that benchmark, and how can you use that?
Yeah, so for us, our framework is meant to help people reflect on how they decide between issues like that, like automatic metrics and human evaluations, or how they specifically do each of those processes. So our benchmark is our framework is amenable to both. I think our follow-up work is going to be to actually apply ECBD in the process of creating an actual benchmark and see whether additional issues arise or whether our ECBD framework and so forth, and guidelines and to help people use it in practice. But yeah, so the idea is this is more like a meta research thing to help with the benchmark design process. So I see that I think there's a lot more work to be done in ECB to validate that it's useful and things like that. But even just getting to this point took like a year and a half because it's really tricky to make sure we get our definitions clear and to make sure we don't mislead, especially because terms are often used in multiple ways. So within NLP itself, but also between fields. So for example, we renamed a bunch of things from ECD, because in ECD, they use terms that would be easily misunderstood in the NLP context. So we have to clarify all these things, and there are also connotations of terms, and so it's a lot to make sure that it to be as clear as possible. And I'm sure people will take issue with some of our terminology perhaps, but we try our best. And so, and I think the next step is to then apply it and see.
It's a very broad question. Thank you both actually for your talk. It's very interesting. But do you feel that a community like ACL will go through evaluation? Because, I mean, more and more benchmarks are arriving and people just care to have a maximum score on whatever benchmark there is currently, and they don't care about, I mean, I don't think they care, there is place for caring about that in such a community. So how would you see things evolving? Like, you think you can make a path through ACL, or do you think that a new conference or whatever should come up to care about that?
Yeah, and maybe I can keep my thoughts. So I think that there will be increasing interest, and there has been increasing interest, and I think it will become more and more prominent. A big reason might simply be because a lot of the models are now too big to be run in academia, and so they're behind some companies' service. And so then what the research community, either we do something entirely different that's not LLM and is still modeling, or like we focus on other aspects of the whole problem. And I think there's more and more recognition that we're optimizing for not necessarily the right things. And so then what should be the right things? I think, at least for me personally, that has been my journey, right? Like I did more modeling work earlier, And then over time, like I saw the probabilistic methods I worked on was replaced by neural nets, and the neural nets are doing great, but then you look at the output and there's issues, and that's how more and more evaluation work. So I think that's going to be more researchers have been going through the same evolution from what
If I could just make a comment. I mean, I think the field is getting broader. I think it's still, as you agree, it's still very heavily weighted, but I am seeing more papers appear on these other topics, like even user needs requirements, stakeholders, that stuff. I think there is more of that happening, so it is progressing. Maybe too slowly, but I think it is moving in the right direction.
I think the efforts on reproducibility that you're working on that will do a huge benefit to the community, because when you look at in detail about some papers, they are not properly evaluated. They just pick the best one that cannot be reproduced. So if you impose or you just add that constraint that the results should be reproduced, then that will increase the quality for sure. And I think the community is not moving yet to that point, but if we are aware of the problem, the community may move toward that goal. And then if I take the information retrieval field, was some time ago when we just compare the results from two different systems. We just compare two numbers, and then there is a sudden movement about the statistical significant test, and that start to be imposed as a standard. So every paper that claims to make improvement should prove that statistically. I think there could be some movements.
That's a great point. I think anytime something is standardized, we also need to make sure people understand why they should do it, so it doesn't become a box-checking exercise. I think for statistical significance, sometimes when that has been imposed as a standard, people run the test, but they don't understand the test, and then that leads to other issues. And I think the same thing can happen with like reproducibility checklists and things like that. So I'm more wary of making things mandatory for these reasons, although maybe it's still a good idea. But like, I think it's important to try to get people to learn more about the fundamentals of why these are important and the limitations of interpreting p-values and things like that. And I totally agree with you.
And I think one thing that would really help is, like in medicine, obviously, as a paper is published, people can criticize it. It may even be withdrawn in some cases, right? We don't have that culture, right? But if you imagine a culture where people reproduce experiments, if they can't be reproduced, perhaps because people were cherry picking 10,000 random seeds, if that's paper, then it has to be retracted. And that's a black mark against the author, which happens in medicine, right? We could go that same path, maybe that would help.
No, but that doesn't occur often if you take into account the number of papers that are published in medicine.
Yeah, but I think sure, but the fact that it can happen,
Yeah.
I think makes people in medicine more careful. And again, even it doesn't happen very often. If you know that if someone tries to use a paper and fails, that's a black mark. That's could be useful, even if it's not very often.
The number of retracted papers in medicine is not low.
It's like 2%.
Sorry?
2%.
Oh, I've read different numbers. That it was really above 10%, 20%. I mean, I suppose this is not the same, maybe the same kind of journals, but I've heard about really, I mean, amazing numbers. I couldn't believe.
There's a great website called Retraction Watch where it's medical stuff. I think I'm probably out of date, but they said at one point 2% of papers were retracted, but 10% should be retracted. Something like that. But I'm probably out of date.
Okay. So we thank our presenter once again.
next month.
Je pensais que c'était pas très important.
Thank you all.
Thanks for your talk.
Yeah, they're in person tomorrow, but when
We've already had my talk, so.
Yeah, I'll tell them it's business to go.
So yeah, a lot of it is, how can we encourage people to do the right thing? There's no rocket science.